This is the part when you open up your foldable. So you should have cut on the dotted line. Don't talk while I'm talking. And then if you open up the very top, we have our title of our foldable, exponential functions. All right, so our exponential function is a function with a variable. So our first blank, put in variable, please, as the exponent. Second blank, exponent. I'm writing, you're writing. All right. Exponential function, is a function with a variable as an exponent. Give me a second, I'll get it right. All right, third blank. Let me get this on here. Come on. Come on, where are you at? There it is. All right. All right, guys, look at the board. Here we go. You need to know that the form of an exponential function looks like this. Y equals a parentheses b to the power of x. This is where a does not equal 0. This is how I show it does not equal 0. Stop talking and continue conversations while I'm instructing. Just focus on me. B is what's inside the parentheses. That's the base of the exponent. B for base. The b is any positive number. Okay. Nope, not for this, what we're doing, okay? And it's a real number that does not equal 1. So positive numbers. Real numbers are all numbers like fractions, decimals, but it cannot equal 1. Okay, so let's talk about growth versus decay. So on your first tab on your left, all right, the key information, if you want to get a highlighter to highlight some key things, we're going to focus on what's inside the parentheses, the B. All right. So whenever your B is greater than 1, okay, whenever your B is greater than 1, that's going to indicate that the function is going to increase. The first blank is increase. And anytime our function increase, it's called an exponential growth. So the next blank is growth. Okay? An exponential growth. When you read your functions, you read your graphs, you're going to read them from left to right, just like always. So this next part is talking about the graph that they gave you. If I look here, and I read the graph from left to right, start with the left arrow, this graph is going up, it's increasing. I'm just highlighting the graph so we know what we're focusing on. Okay? This graph would be an exponential growth. Does that make sense? So our next blank here, is also growth. Because what do I see happening? Increasing. Yeah, because it's increasing. And where does it increase at? How do we know that? It's rising, but also I want you to circle the number that we're focusing on is the B. Okay, so right here, our B is 2. Is that number greater than 1? Yes. Yeah, so because B equals 2 and it's greater than 1, then yes, we know the graph is increasing. And the graph increases.
What does that say?
And increases. Okay? All right, so if we have a B, this is saying that B is between 0 and 1. Okay, 0 is less than b, but b is less than 1. So we're talking about b is between 0 and 1. Numbers that are between, I'm just going to add this to your notes, and I want you to add. That means that your b could be a fraction, or it could be a decimal. If it's the b is between 0 and 1, then the function is going to decrease. And we call that an exponential decay. So we should have decrease in the first blank, decay in the next one. All right, so if I read this graph here from left to right, I start over here and I go, it's going down, down, and then it curves and it kind of flattens out. All right, which number in this example represents the b?
5.
Yes, very good, 0.5. I'm just going to circle that 0.5. So this graph is an exponential what? Yeah, decay, good, decay. Yes, because, well, it's between 0 and 1. 0.5 is between 0 and 1, because here our b equals 0.5. Which means, yeah, and the graph decreases.
Shut up, Abdul. I'm already talking.
Will you stop?
For real, bro.
I'm talking to you.
Oh, but he's talking to me.
Just stop.
Oh, what? He just told me to shut up.
What did I just say? I know I said stop.
That was my fault, bro.
I didn't put any blame on anybody. I just asked you to stop. I don't need the back and forth between y'all. I just needed to stop. Okay, so you two. All right, so the next thing that we need to focus on the parts of the graph, and I probably need to rearrange this. So I'm going to go to initial amount. Okay, so go to the next tab to the right. Go to across. Are y'all with me? Okay, so we're going to practice using graphing calculator to help you problem solve. So they want you to fill out the table, identify the initial amount. They've given us the function right here, f of x equals 4 parentheses 2 to the x power. Yeah. So basically, do y'all know what this means to do if I see f of x? Yes. What does it mean? Oh, come stop. Guys, back here. Back here. Stay focused. Train your mind right now to stay focused. What are you doing? What are you doing? Where in the calculator? That's what I'm asking. Yes, this f of x is the same as y equals. That's what I'm trying to get to. Stop it.
What did I do?
You know what you did. So think of f of x is the same as y equals. So go to your calculator, hit the y equals. I'm going to clear this out. 4 parentheses 2, then use your caret to get to the x power. Oops, sorry, delete that. I got an arrow to the right and close it, right? Isn't that what we have? All right, now how do we get to the table?
Second graph.
Very good, second graph. Our table, we started at -1 for our table? Okay, all right. Oops, sorry, second graph. Y equals, we just go to y equals to make a table, guys. All right, so we're going to fill in our table. So we go back here, just copy our values. At a -1, what do we have? In it, wait. Oh, 2. Then 16, right? Then 32. All right, good. Okay, so underline this word, initial amount. Okay, your initial amount in your table is right here where it's at x equals 0. So if you want to circle that row to show that this is your initial amount.
Wait, how do we know it's that one?
Because it's always the y-intercept. Yeah, it's where x is 0. So its starting point is at 0. So your initial amount here would be at 0, comma 4.
Exponent is 0?
The exponent would be 0. Yes, you're right.
Oh, no, I meant 4.
Well, 0, 4. Okay, so the initial value of the following function. Now, if I gave you what you need to understand is, and I'm going to come over here to the right. In a exponential equation, you have a question? What is it?
So when you always look for initial amount, go to 0.
Say that again?
You always have to go to 0.
Yes, to find the initial amount, yes. Okay. Now, if you're just looking at the equation, the initial amount is your number in front of the parentheses, the number that's going to be multiplied to the b. So this would be the 4 right here. Do you see how the 4 is in front of the parentheses? So that's your a in the form.
Oh.
So a represents the amount at the beginning, and this is when x equals 0. The beginning has to be at 0. So this is also known as your, and you know this part, you've heard this word before, your y-intercept.
Oh, what's so funny about that?
Okay? The a in the equation, in the form, is your initial amount.
So that's where, like, if we were going to plot it, that's where we put the first dot.
Yeah, well, that's going to be a point, yes. Okay? And so if you were going to look, like, for example, we're looking at the two graphs that they gave us down here, okay? The y-intercept is where the curve of our graph, right, touches the y-axis. So all I'm going to do is right here, circle where I see that happen. Okay? At 1 here.
And a 1 there.
Nope. And the other one is at
3.
At 3, right? Are we okay? All right. So notice that at 1, you see how there's no number being multiplied to this? Remember, we don't see a number. We always know it's a visible 1. Okay? So the initial value for this following function would be 0, comma 1. Yes, that point. All right. The initial value for the second exponential function. Yep, 0, comma 3. Okay? It always correlates with the number that represents the a. All right. Now, so just not the only thing that's new about this, guys, you know y-intercept, that's never changing. You still have to know that characteristic on a graph. The y-intercept, another word that correlates with y-intercept is initial value or initial amount. All right, now, this is the new word, horizontal asymptote. Which I know, I sound like a asymptote. I'm not just saying asymptote. Say the whole word, okay? No, okay.
Ask me for Toto.
Okay. All right, y'all know horizontal means looking left and right.
Yes.
That's a horizontal line. Who remembers what the equations of horizontal lines are?
Y.
Yes, very good. Y equals and then a number. So this is important. Okay. No, horizontals, y equals a number. So you can add that to your tab. Okay? Now, here's the thing. Exponential functions, okay, they approach lines. They never pass your asymptote. So the horizontal asymptote is a horizontal line that the graph approaches. It never crosses. It just gets real close to it. Okay? Approaches. Yes. Yeah, go. Okay, so read your graph. Like in this first example here, underneath, the graph goes from left to right. So what you want to find is where does the graph, the curve kind of flatten out?
At the top right there.
Yeah, okay, so we're going to add the horizontal line there, like we just said. So I'm going to make a dotted line that's horizontal right here at the top. Okay, we got that? All right, so this is where basically your horizontal asymptote will be the highest point on the graph or the lowest point, just depending on how the graph looks.
The highest point right here.
Yeah, okay, so what would be the equation of that horizontal line? Where is it cross the y-axis? So we would write y equals -1. That's the equation of our horizontal asymptote.
Oh, that's so.
All right, so let's look at the next one over here to the right. Okay, so read the graph from left to right, find where it flattens out. Where is there?
Is 0.
Yeah, okay, so yes, there it is. It happens at 0. So y equals 0 is the equation for the horizontal asymptote. Oh, so y'all automatically see it, huh?
Yeah.
Very good. Y equals 2. Now this is important. You have to know your asymptote because the range correlates to that. Knowing your asymptote goes with the range. So do we have this down? Are we okay on these? Are we ready to go to the next tab? Okay, I heard a wait. I'm gonna wait.
What's range again?
Range is y values. Range are the y values. So this is why this goes together because we have y equals, right?
The range be 2. Like for let's say the y equals 2.
Well, no, because your y is gonna be greater than or equal to. Okay. All right. So So domain and range.
Well, equals be quiet. I can't pay attention.
I wasn't talking.
That's hard. Wait, did all the other classes do this?
Not everybody, just some.
Because we were showing them what we worked on yesterday, like, oh, we did that on Friday.
Okay. So domain is the set of all x values. Okay. Stop it. All right. Understand. Focus. Focus. You got to train your mind to be focusing right now. Focus, Julian.
Bro, he can follow, bro. I'm not good at something, man.
Why don't you just sit on there?
Let's not be violent.
The graph of an exponential function, it will extend forever to the left and to the right. Okay, because
X.
domain is x. So you're looking at the x-axis, left or right.
So the right that's the bottom domain.
Well, domain is your x values.
That was not.
So what you have to remember is, this is just a fact. Just remember, this is your answer always for any exponential function. Domain is all real numbers. It's always going to be all real numbers. We have a symbol for that. That's like that double R.
So it's like infinity.
Infinity to infinity, yes. Negative infinity to positive infinity, yes. Now, your range, since that represents the y values, in order to do the range, you have to identify this first little second blank here is the horizontal asymptote. So it says first, identify the horizontal asymptote. Then determine if the function is above or below the horizontal asymptote. Okay, so we want to determine, do I see that graph above or below that horizontal line? Now, if right here, y is above, right here, if it's above, then it's going to be y is greater than. And they just abbreviate HA as horizontal asymptote.
So like if it's above, it's greater than. Below, it's less.
Yeah, so if it's below, then you would use less than.
Oh, that makes it even easier.
Yes, so here we're going to do, over here, we have this graph. This is your curve right here, flattens, and then it goes up real fast. Okay, what's the D represents what? What do you think the D represents? Domain. So what are we going to write right here? Because it's always the same answer.
The domain. All real numbers.
All real numbers.
Oh, no way.
Just put the symbol, all real numbers. The domain is always all real numbers. Okay.
Then what do we write there?
All right, well.
Okay, so find the horizontal asymptote here.
It's below 0.
It's
Yeah, it's 0. Now, is this graph above the line or below?
Oh, God.
Above. So we would write y is greater than 0. If it's above, then it's greater than.
And then right
That
here is
line
below.
above what is it?
Right here is above the x-axis, it's above it.
If my purple curve is the graph.
If it's
Oh,
above
okay,
the
so-
x-axis.
Yeah. So if it's above this horizontal line, if it goes up, yeah, then it's greater than.
If it's below it, right?
Okay. All right. So look at the second graph. For the domain, what are we gonna write? All real numbers. Done. Now look at your graph and find the horizontal asymptote.
So why is
Give me help.
Yeah, yep, it's below this line, so it's gonna be y is less than -2, -2, -2. Wasn't it at a -2 for the horizontal line? Okay.
So whatever line is below it, that's less than that number.
Uh-huh.
If it's above it, it's
Greater. Yes, exactly. Okay, so what I want us to check, because some of you picked some answer choice here. Now we have a better understanding of some parts.
Yeah.
Okay. Okay. So let's check if we picked the right answer choice. Okay.
I picked
Really?
Z.
All right. Here's what you need to focus on. Which number? Well, this one's the same, but this right here, your initial amount is this number here,
Yeah.
the initial amount. So that would represent, if this is my initial value is at 0, 2, that's the y-intercept.
We need to make sure it crosses at 0, 2.
Yep, this first one was A, and some of y'all picked,
Man, the graphic calculator gave me.
some of y'all picked B, and that wasn't right.
How do you know?
So
It's A,
we're wrong. So why?
because it crossed right here at 2, and you have to pay attention to your scale. Okay. All right, so let's think about this next one. On number 4,
Forgot the y-axis on the kids.
you should have picked D on number 4. All right. All right, very good. Okay. So these two guys, both of these need to go in your spiral. Okay, put it in your spiral right now.
Oh, I feel so low.
All right, guys, look at this. This is gonna go after our foldable. This will go with what we just kind of went over. Okay, stop talking while I'm talking, guys. All right, here's what I need you to do. On your space over here, you need to create a table for every problem. And that table is always going to be for this assignment, showing a -2 to a +2. So make the T table, the T column with X and Y. Draw it on your worksheet, please. You're going to use this to help you graph. So when I check, I'm going to check the table, I'm going to check your graph, and then I'm going to check your fill in the blank.
Does it always start with negative?
Yeah, for this one, we're going to always do -2 to a +2. Okay? Are we okay on this part? So make sure you add the table. What you're going to do is, they give you the equation right here. Y equals 3x,
Would it be negative on the first point?
the first point.
Yeah, when it crosses the y. It'd be -1.
Uh-huh. So go to your calculator, hit your y equals. We're going to clear this out. We're going to put 3, then a caret to make the box, x, then arrow to the right so you can type in -1. So you got to type in the equation, then you go second graph to get your table of values. We do have decimals for this first one. You're going to have some decimals on this, okay? Are you all with me so far?
No.
Okay, what do you need?
Can you go back to the page?
It's got the devil.
To the page? To the actual worksheet?
Yes.
What do you need from this?
The numbers.
It's always a -2 to a +2.
Okay.
So would it be 0, 0? Because, you know, 0 is up there.
Well, I don't know if it's zero. Yeah, it goes.
Okay, so at a -2, we're going to put a -0.8. I know it's 889, okay, right? Then for a -1, we got a -0.6. That's repeating, so I'm just going to put a bar over the 6. Yeah, don't keep going with the sixes, please. All right. At 0, we're going to get 0, right?
Yeah.
At 1,
Yeah.
we get 2. And at 2, we have 8.
0.
What is 0? You're,
The graph.
the one we circle?
It will be 0 this intercept.
The y-intercept, yes, is at 0, 0. You're right. The y-intercept is where the x and the is always a value of 0. Yes, please. So at a -2, you're going to come down, and this is close to 1. At 0, at 1, I go up to 2. At 2, I'm going up to 8. So if you're trying to make sure you do your graph correctly, go back to your calculator and just hit graph and sketch it through those points. Sketch it through those points. So, do y'all see where it flattens out at? Yeah, it's gonna flatten out at -1. Very good. All right, so I'm just gonna sketch right here. It goes, and then it kind of curves. Okay.
It's growth.
All right, is this growth or decay?
Growth.
Yes, it is growth. It's increasing.
All real numbers.
Domain, all real numbers, done.
Y is less than -1.
Where's the asymptote?
It's right there, the little line right there.
At where?
-1.
It's at y equals -1. Sorry, negative. I forgot my sign. -1. Now, is this graph above or below that line?
No.
What?
Oh my.
Yeah, I'm with you, Dominic. I'm so with you.
Oh, it's below.
Oh,
How is it below?
What are you talking about? Guys,
are y'all?
Are y'all stupid?
Don't say that word. We don't say that.
Yeah. Yeah.
You really want
Guys,
I'm gonna show your mom.
guys, the graph I'm talking about is the curve. It's the blue line for me.
Yes.
This blue line is above the red line. So my range is greater than -1.
That's what I said.
If it's above, it's greater than.
On my daddy grandma's ashes.
Don't do that. Stop.
We did it. All right, we did it.
All right, guys, I'm gonna have you stop. You'll get to finish this in class because you need a calculator. Nope. You need a calculator to do this, so don't worry about this. All right?
Can we do this tomorrow?
Nope.